there, Algebra 2. Now, listen, I know that this says Unit 6, Day 2 notes, but we're needing to adjust this particular unit a little bit. So this is actually part 1 of Day 1 notes. Also, we're going to be doing a lot of word problems this unit. This first part of notes is dealing with projectile motion, and then it gives you a couple of equations for projectile motion. Well, it gives you one equation, but then it lets you know if you're dealing with meters, you're going to substitute 9.8 for A. And if you're dealing with feet, you're going to substitute 32 for A. If I'm dealing with feet, my projectile motion problem is going to start negative 16t squared. That's what I would remember. And if you're dealing with meters, then it's going to start negative 4.9t squared, and you can disregard that negative 1/2. So if you'll just follow along and do what I'm doing, hopefully it'll make a little bit more sense. Okay. An object is launched directly upward at 64 feet per second from a platform 80 feet high. When will the object reach its maximum height? Now, since we're dealing with feet, our equation is going to begin with negative 16t squared. Now, reading again, it says an object is launched directly upward at 64 feet per second. That's the velocity. So that's going to be our next term, plus 64t. So when you're dealing with feet, it will always start negative 16t squared, and then whatever that initial velocity is, that will be your second term, give it a t. And now the next part is going to be, well, where did we start? We didn't start from the ground. We actually started 80 feet above the ground. So what we have is a quadratic here. The A term, if you're dealing with feet, always negative 16t squared. The B term, always the initial velocity. And the C term is, well, where did you start? How high up from the ground? And we started 80 feet high. This entire unit is going to be graphing calculator, so you can use your graphing calculators to find this. And we're going to start by, when will the object reach its maximum height? So you're going to go ahead and turn that calculator on, push y equals, clear out any previous data, and then we're going to enter in the equation that we see on my screen. Negative 16, that button is the button we need. It represents t in this case. Then we're going to square that, plus 64, hit that button again right there, and then plus 80. And then let's graph it. Okay, now if we're going to solve when will the object reach its maximum, we have to find, well, where is the maximum? Now, this particular parabola looks something kind of like this. That's its path trajectory. So our maximum is somewhere up here. Now, don't worry about the fact that we can't see it. Your calculator knows where it is. Here's what all you need to be aware of. Our maximum is somewhere in between negative 10 and positive 10. That's our scale on the x-axis. This is negative 10. This is positive 10. You're going to be using those values a lot today. So we're going to push second trace. Remember, we're trying to find the maximum. And then when it says left bound, just push negative 10, enter. When it says right bound, push 10, enter. And when it says guess, just push enter one more time. Now here's what it's giving you. It's giving you the vertex. I'm going to write that down. I'm going to round the x value to 2, and the y value is 144. We have found the vertex of this parabola. This is how high it's going to go. That's the maximum height. And then this right there, that's how long it takes for it to get to its maximum height. So when will the object reach its maximum height? That's going to be at 2 seconds. What will that height be? Well, the maximum is 144. And then when will the object reach the ground? So let's bring back our graph here. I'm going to push graph one more time to clear that previous data. Now that x-intercept right there, that represents ground zero. If we can find the x value there, that will tell us when our projectile is going to hit the ground. So push second, trace, and now this time we want the second option, 0. We're trying to find ground 0. Now, you don't want to use -10 and +10 in this scenario. You want to use 0 and 10 because this is the x-intercept that we're trying to find. It is somewhere in between 0 and 10. So when it says left bound, push 0, enter. When it says right bound, push 10, enter. And when it says guess, push enter one more time. 5, 0. That's what we got. We got 5, 0, meaning it's going to reach the ground 0 feet in 5 seconds. The next example, Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. The height of the cliff is 480 feet, and his initial upward velocity is 16 feet per second. So we're dealing with feet. So we're going to start -16t squared. His initial upward velocity is 16 feet. That's our next value. So plus 16t, and then he jumped off a cliff 480 feet in the air. So plus 480. How long does it take Jason to reach his maximum height? So let's find the maximum. Push y equals, clear out the previous function, and now let's enter in this one here. And graph it. Okay, our maximum is somewhere up here. This parabola goes like this. Woo! So it's somewhere up there. We know it's somewhere in between -10 and +10. So second trace, we're trying to find the maximum. So select that option. When it says left bound, push -10, enter. When it says right bound, push 10, enter. And when it says guess, push enter one more time. And we now have the vertex. We're going to round the x value to 0.5. And then our y value is 484. Remember, this value represents time, and this one represents height. How long does it take Jason to reach the maximum height? It's going to take 0.5 seconds. What is the maximum height? 484 feet. And when will Jason hit the water? So let's go back to our graph here. That x-intercept right there, that represents when he's going to hit the water. So let's put second trace. We're trying to find ground 0. When does he hit ground 0? Push enter. Now that x-intercept is located somewhere in between 0 and 10. So when it says left bound, push 0, enter. When it says right bound, push 10, enter. And when it says guess, push enter one more time. 6, 0. When will he hit the water? He will be at 0 feet. That's when he hits the water in 6 seconds. And then example 3. Billy hits a golf ball. I wonder if his last name's Madison. Billy hits a golf ball directly upward from the ground with an initial velocity of 25 meters. We're dealing with meters this time per second. So your equation is going to begin -4.9t squared. The initial velocity, that's our next value. They tell us it's 25 meters per second, so plus 25t. And they hit the golf ball directly upward from the ground. So we don't need to worry about a c value here. How long is the ball in the air before hitting their fairway? What they're asking is, when will it hit the ground? So push y equals, let's clear out the previous data and enter in the new data. And graph it. Okay, remember this x-intercept right here, that's where the ball is going to hit the ground. So push second trace, finding the 0. It's somewhere in between 0 and 10. It looks like it's going to hit the ground in 5.1 seconds. How high does the ball go? That means we now need to find the maximum. So let's push second. Oop, let me get out of here. I'm going to graph it one more time. Second trace. If we're trying to find maximum height, how high does the ball go? We need to find the maximum. Here's the maximum. It's somewhere right about here. This trajectory goes something kind of like this. So the maximum we could reason is right about there. That's somewhere in between -10 and +10. So for left bound, push -10. For right bound, push +10. And when it says guess, just push enter one more time. The maximum height is right here. Let's round it to the nearest hundredth. That'll be 31.89. Meters. Okay, that takes care of Unit 6, Day 1, Part 1. Part 2 will be coming soon.